Have you heard about the asteroid that could hit Earth? The impact of asteroid 2024 YR4 is estimated for December 22, 2032. The chance of this happening is 1.9%, which is very high for astronomers. Only one other asteroid measured since we have had telescopes has had a higher probability of impact. The asteroid 2024 YR4 has a diameter between 50 and 100 meters. It is larger than the asteroid that caused the Chelyabinsk event in 2013 and is comparable in size to the object from Tunguska in 1908. If it were to impact Earth, it would release energy equivalent to about 8 megatons of trinitrotoluene, nearly 1,000 times greater than the Hiroshima bomb. It won't destroy the planet, but entire cities would have to be evacuated. Fortunately, the asteroid is rocky, not metallic, so it's possible that no crater would be formed after the impact. The risk of impact will be adjusted over time as the asteroid's trajectory is measured. More precisely, in 2028, we will most likely know whether it will hit Earth or not. It is expected that the risk of impact will drop to 0, because right now it is 100. If not, and if we discover that our planet is in the asteroid's path, we will still have 4 years to prepare for impact. It is already being suggested to prepare a space mission that would try to deflect the asteroid enough to avoid a collision with our planet. What would you do? Everyone is talking about the Chinese sun. Their nuclear fusion reactor operated for 20 minutes. That's double the previous record of 10 minutes. Why is it so hard to sustain a nuclear fusion reaction? To mimic the process at the heart of stars, you need temperatures of at least tens of millions of degrees Celsius for the hydrogen plasma in the reactor. At these temperatures, if the plasma hits the walls, the reactor explodes, which is not good, so the plasma is kept in a vacuum away from the walls by very strong magnetic fields generated by superconducting magnets. The major problem is the instability of the plasma. The particles in the plasma move chaotically, and these movements can generate turbulence that leads to the loss of the delicate balance required. Maintaining the reaction and the plasma, it can damage the walls. To prevent this from happening, the heating systems that operate at extremely high capacities must ensure continuous stability. In the case of the Chinese reactor, the heating systems use twice as much energy, equivalent to that of 70,000 microwave ovens. While maintaining stability, the 20-minute record for sustaining stability is remarkable. In the future, a similar system is set to be installed at the upcoming International Thermonuclear Experimental Reactor Experimental Fusion Plant in France. Maybe, who knows, we'll solve this great mystery of nature and produce clean energy through fusion by copying the process from the sun. What do you think? Will you live to see the times when the energy from the socket will come from such an artificial sun? Look at these 3 small red dots photographed by the new James Webb Space Telescope. And this one, all of them are a new mystery of the cosmos. We know about these cosmic objects that they are small, that's why they haven't been seen until now by other telescopes. They have a diameter almost 100 times smaller than our galaxy, and their reddish color suggests to us that they are far away due to the Doppler effect. Because they are far away, we see them as they were when they were babies. Somewhere between 600 million years and 1.6 billion years after the Big Bang, and it's been 13.8 billion years since the Big Bang. But what are these small red dots? It's suspected that they are small galaxies in formation with very powerful active nuclei. At their center, there would be supermassive black holes with active accretion disks, through which the black holes capture the surrounding hydrogen gas and grow larger and larger. Their reddish color is in part real as well. It comes from the accretion disk that generates luminous energy as matter irreversibly falls toward the black hole's singularity. I imagine these active nuclei as giant engines at the heart of the small galaxy. From there, where matter spins as it falls toward the black hole. From the center, at incredible speeds, releasing energy like a cosmic fireworks show, yet mysteries remain. The infrared spectrum of these small galaxies is surprisingly uniform, and the X-ray emissions expected from active black holes are missing. The constant brightness of these small red dots stands in stark contrast to the irregular behavior we expected from a supermassive black hole consuming surrounding matter. It is believed that these small red dots hold the key to another mystery. They might explain how galaxies in the early universe grew so quickly. What do you think about the Big Bang? What fascinates you about it? Have you ever wondered what a meteorite sounds like when it crashes to Earth? Well, you can stop wondering because now for the first time a meteorite crashing to Earth has been filmed by a video camera, sound included. Look, here. It happened in Canada. A homeowner who had just taken his dog out for a walk recorded the sound with his surveillance camera. At the moment when a meteorite crashed to the ground, experts believe that the sound captured is the direct result of the meteorite's high-speed collision with the Earth's surface, providing valuable data about the energy released. So now you also know what this sound is. If you hear it, look around to see if a meteorite hasn't fallen near you. We live in a world of the internet, but the internet we see today is seen differently from today, the inhabitants of this planet. When I want to travel virtually and see what those countries look like, I use a VPN. Surfshark is a VPN that gives you access to over 3,000 servers in 100 countries all over the world. Surfshark hides your IP address and thus ensures your virtual privacy. When browsing the internet, you can search for plane tickets, hotel rooms, and rental cars at lower prices. This comes with a minimalist and user-friendly app design. With the Surfshark Alert service, you can receive alerts and benefit from real-time protection, and Surfshark Antivirus helps you keep your device virus-free. You can do a quick or full scan of your device, benefit from real-time protection, and schedule scans. Go to surfshark.com pressure and get 4 extra months of Surfshark. Listen, Earth is special. That's why we care about it. But our galaxy, recent studies show that it's special too. In the Satellites Around Galactic Analogs project, over 100 galaxies similar to the Milky Way were studied, and surprise, they are significantly different from our galaxy. Our galaxy, the Milky Way, boasts 4 small satellite galaxies, such as the large and small Magellanic Clouds, both active in generating new stars. The Saga survey revealed something unexpected. The other similar galaxies each have many more satellite galaxies, and these satellite galaxies are actively producing new stars. For us, only the Magellanic Clouds continue to form stars. The others are just companions to our galaxy. They have become mostly silent as if they are in a retirement community. Why does this happen? Maybe dark matter suppresses star formation in the satellites that orbit too close. Maybe our galaxy had a tumultuous past, a dramatic interaction, or a merger with another galaxy which left a mark on its satellite system. Whatever the cause, the new results suggest that our galaxy might be more of a cosmic exception than a rare standard-type spiral galaxy. So, when you look up at the night sky and see the stars of our galaxy, ask yourself how special this place is. Don't hate me for saying this, but there is no evidence that artificial intelligence can be controlled. That's what Roman Yamposhi says after studying hundreds of scientific articles. Think about it. Before we commit to creating super intelligent machines, shouldn't we make sure we can keep them under control? But here's the surprise. The more autonomy machines using artificial intelligence have, the less control we have. Have you ever heard of the term black box? In the world of artificial intelligence, that means the system's decisions are often mysterious and hard to explain. Roman Yamposki points out that if we can't understand how artificial intelligence makes decisions, how can we trust it? This lack of transparency can lead to errors or even dangerous decisions. And as artificial intelligence becomes more autonomous, our ability to control it decreases. Roman Yamposki argues that less intelligent agents like us humans simply cannot permanently control a super-intelligent system. It's like expecting a small child to operate a spaceship. Nice in theory, but disastrous in practice. And there's something else. We want to program artificial intelligence with human values, but here's the problem. If you insist too much on aligning artificial intelligence, you might end up with a system that says no when you need it, or worse, one that misinterprets what you really want. This is a paradox for artificial intelligence. It can't always obey humans and protect humanity at the same time. So what's the solution to the lack of control over artificial superintelligence? What do you think? Thank you for watching the video until the end, and thanks to Surfshark for sponsoring it. Get 4 extra months of Surfshark. If you haven't subscribed yet, you can do it right now by clicking this subscribe button. Until next time. I'm Christian Presura from Fisica Povestita, and I wish you all the best. Goodbye.